Chapter 2, Section 4, we're going to be solving an equation with variables on both sides, and this is what it's going to look like. Mr. Seals weighs 101 pounds and is gaining 8 pounds each month. Mr. Thomas weighs 205 pounds and is gaining 4 pounds each month. In what month and year will Mr. Seals weigh the same as Mr. Thomas? Now, there's a lot of ways to figure this out. You could make a table. You could make a graph. You could make an equation. If we want to make a table, what we do is let's list 3 different columns. The month, it's October, and then go down the list. And we make a column for Seals. Each month we list out how much Mr. Seals weighs. And then Mr. Thomas' column lists out how much Mr. Thomas weighs. And we could go down the list, go down to 12. We'd have to go really, really far, skip a few so that it fits onto the PowerPoint. Finally get down to 26 months later, and they weigh the same, 308 pounds. Useful, something that you can always do, takes a while because you're going to have to list out a lot of different values. A graph is useful as well. We can graph these 2 different input-output values. Basically go 1 month is how much, 2 months is how much, 1 month is 105 plus 8, or 101 plus 8, which is 109, 2 months, etc., and go along that way. Here's the months, here's the pounds, and so there's would be a list of all my weight as the months roll by. If we could graph Mr. Thomas's, it would be a lower slope, a slower slope, because he only gains 4 pounds every month. And at some point, we are the same. That is the point at which we'll find our solution. 26 months later, 308. Remember from the table that that's what we saw as well. It represents 26 months later, or 308 pounds each. The most effective way to figure out problems like this is to make an equation. To find my weight at any given month, I can find the sum of my weight and the pounds I gain per month. So there's my weight, pounds I gain per month, and that's the sum of each. I put 8 times m because I multiply how many months have gone by 8. So if 10 months have gone by, I multiply 10 times 8 and then add it to 101. Same with Mr. Thomas. Take the beginning weight and add 4 pounds per month. If I want to find where we weigh the same, where we are equal, set us equal to each other. So my weight and Mr. Thomas's weight are going to be set equal to each other, and we're going to solve them. That means we need to figure out how to solve an equation with variables on both sides. Here's how you do it. You've got to remove a common value of terms from both sides, and that means I have to get rid of the 4m or the 8m, either one. Now, the best way to do this is to make sure that you still have positive m's left over. If I subtracted 8m from this side and I subtract 8m from this side, I'm going to have negative 4m left over on this side. So it would be best to subtract 4m from this side and 4m from this side. When I do that, I have no m's left over on the right side and 4m's left over on the left side. So we removed a common value of terms, 4 of them, until we got rid of them from one side. Now it's a 2-step equation, so we get rid of 101, then we got 4m equals 104, divide each side by 4, and you get 26. And there's that 26 again, just like the table showed us, just like the input-output from our graph showed us. And that would be the answer. We'd still need to interpret what that means, but this is by far the quickest way to find that out. So try this one. 6x plus 3 equals 8x minus 21. Answers are either A, negative 3, B, 12, C, 5, or D, 14.7. For similar problems, do page 98, numbers 3 through 16 all.